And that's always the cynic's perspective. However, the optimist perspective would say, but if you don't build it, they can't come. And that's usually how we look at the world. We have to reason about intuitively why this would be very useful. And in fact, in 2012, Ilya Sutskever and Alex Krzyzewski and Jeff Hinton in the University of Toronto, the lab that they were at, they reached out to a GeForce GTX 580 because they learned about CUDA and that CUDA might be able to be used as a parallel processor for training AlexNet. And so our inspiration that GeForce could be the vehicle to bring out this parallel architecture into the world, and that researchers would somehow find it someday was a good strategy. It was a strategy based on hope, but it was also reasoned hope. The thing that really caught our attention was simultaneously we were trying to solve the computer vision problem inside the company, and we were trying to get CUDA to be a good computer vision processor. And we were frustrated by a whole bunch of early developments internally with respect to our computer vision effort and getting CUDA to be able to do it. And all of a sudden, we saw AlexNet, this new algorithm that is completely different than computer vision algorithms before it, take a giant leap in terms of capability for computer vision. And when we saw that, it was partly out of interest, but partly because we were struggling with something ourselves. And so we were highly interested to want to see it work. And so when we looked at AlexNet, we were inspired by that. But the big breakthrough, I would say, is when we saw AlexNet, we asked ourselves, how far can AlexNet go? If it can do this with computer vision, how far can it go? And if it could go to the limits of what we think it could go, the type of problems it could solve, what would it mean for the computer industry, and what would it mean for the computer architecture? And we rightfully reasoned that if machine learning, if deep learning architecture can scale, the vast majority of machine learning problems could be represented with deep neural networks. And the type of problems we could solve with machine learning is so vast that it has the potential of reshaping the computer industry altogether, and which prompted us to re-engineer the entire computing stack, which is where DGX came from, and this little baby DGX sitting here. All of this came from that observation that we ought to reinvent the entire computing stack layer by layer by layer. Computers, after 65 years since IBM System 360 introduced modern general purpose computing, we've reinvented computing as we know it.
To think about this as a whole story. So parallel processing reinvents modern gaming and revolutionizes an entire industry. Then that way of computing, that parallel processing, begins to be used across different industries. You invest in that by building CUDA. And then CUDA and the use of GPUs allows for a step change in neural networks and machine learning, and begins a sort of revolution that we're now seeing only increase in importance today.
All of a sudden, computer vision is solved. All of a sudden, speech recognition is solved. All of a sudden, language understanding is solved. These incredible problems associated with intelligence, one by one by one by one, where we had no solutions for in the past, desperate desire to have solutions for, all of a sudden, one after another get solved, every couple of years. It's incredible.
Yeah, so you're seeing that in 2012. You're looking ahead and believing that